This is a Fluke 6160A frequency synthesizer. This device will generate synthesized frequencies from 1 to 160 megahertz, and it does it in two ranges here. You can see 1 to 12 megahertz and 10 to 160 megahertz. And of course your resolution is finer in the lower band, and then it's a little bit more coarse in the upper band. I wasn't able to find a manual for this. I looked all over the internet. I was able to find a Fluke 6160B service manual. So I'm hoping that the two of those units are fairly close. That Fairchild curve tracer that I did a few videos back, between the A and B units, they completely redesigned it, and it was a really different beast. I had a heck of a time with that. So hopefully this one will be similar between the A and B models. I was able to download the Fluke 6160B, as I said, and the date on this one says revision 1 is 7 of 74, to give you an idea of the age of this unit here. This is out of the service manual, section 1, and it's got some of the specifications here. It says two separate ranges, 1 to 160 megahertz, and two separate ranges, 1 to 12 megahertz and 10 to 160 megahertz. The resolution is 0.1 hertz in the 1 to 12 megahertz range, and 1 hertz in the 10 to 160 megahertz range. And the output signal is adjustable from +3 to +13 dBm into 50 ohms. So that's basically the specs on the unit here. If you'd like to learn more about this service manual is on the internet here. Like I say, it's the B unit. It's not the A unit that I have here. So, like I say, hopefully they'll be fairly similar. So before I power it up, I'm going to pop the lid on this thing and we'll take a look inside, see what it looks like. This is another unit that came from a Hamfest, actually a couple years ago now. So it's been sitting out in one of my buildings. Here's a look inside of the top of the unit here. Very well constructed. You've got two main boards in here. Looks like this is a digital board. There's some levers here, and it looks to me like if you remove a few screws here, these panels will tilt up where you can get access underneath. I'll have to check that out. They've got some little handles on here made out of cable ties here. Here's a connector on the back. I'm assuming that would be for some type of remote operation. Maybe like a GPIB bus, something like that. A little bit of corrosion on that connector. The rest of it looks really clean. Boy, nothing but quality parts in this thing here. A lot of the chips are on sockets too, which is interesting. I'll have to reseat a lot of those. You get chip creep over time on these things, and that can cause intermittent operation. So I am going to turn the unit over and we'll take a look on the underside next. Here's a look on the bottom of the unit. Let's see, I had 3 screws in the front and the back, and then we had a couple screws along the side. I did notice that some of the screws were straight blade and some were Phillips. That's kind of a bad sign, but it came out of a Hamfest, so that's what happens. You buy something from a Hamfest, you're not going to get many calibration stickers that are intact too. That's another thing I found. Anyway, here's some of the RF goodness. Piece of a spider maybe? I don't know. Some of the RF goodness here and all the connectors. These are not in these are not in plug-ins. Pretty sure. Doesn't look like it anyway. But here's all your interconnects for the RF. Power supply. Must be back in here. Here's the AC input. I'm assuming there's a transformer in. Here's a screw missing here. Not a good sign. Heat sink for the power supply. You got your outputs in the back here, which are upside down right now. Yeah, BNC on the output. There probably was an option to have a output on the front. Here's a plug over a hole. It says RF out. So if I get this thing running and I'm going to actually use it, I'll probably put a outlet on the front of it. It's a little more versatile that way. So I don't know the condition of this thing. I don't know if it works. I'm going to check the fuses, and if they're intact, I think I'll just plug it in and we'll see what we get. Normally I put it on a dim bulb, but I'm going to gamble and take my chances, so that's next. Well, the fuses checked out okay, so I plugged it in, and it's in the off position, but I am getting a slight hum. This may have some kind of a crystal time base, ovenized time base in it, I'm not sure, but I'm going to go to the 1 to 12 megahertz position, and we're getting, let's see, power light comes on, this came on, and the decimal's changing, and let's see if we got any output. We don't have any output, so yeah, I'm varying the output level to get 0. Let's go to 10 to 160, and we still have nothing. So no output. Well, I think that's why it was in the free pile at the Hamfest. So I guess we're going to have to troubleshoot this thing. Hopefully the service manual for the B unit is similar to the A, otherwise this may be a lost cause. Although lots of really nice parts in it. Well, this is interesting. I now have output, and all I did, I went in and I pushed down on all the ICs here looking for chip creak, and some of them I would push, I'd get the crunching sound and crunching feeling. So you know, these chips have been in these sockets for 50 years at least. So now I have output, although I'm getting a little bit of level shifting here, just a little bit. I can control the output, and you can see right now 1.4 megahertz, but the controls are acting goofy here. For instance, I've got it 1 0, should be 1 megahertz, right? And I got 1.4. Now as I turn this knob, okay, now I've jumped up to 2, which is good, but now when I go to 3, no change. I go to 4, jumps up to 4, but you can see a lot of jittering on here. Well, now it's on 5 here. Let's go back to 3. 3, 4. Okay, now I see it's not changing here. Keep going. Now it jumps up. On 8 it jumps up to 11. So and some of these don't have any effect at all. No. Now these wafer switches on here, they're all open wafer switches, and I can't see if there's a lot of corrosion on them. So what I think I'll do next, I'm going to clean those switch contacts off and see if I get any changes. That could be part of the problem too. And I should probably check the power supply. I may have some ripple on there. I can hear a little bit of humming. Anyway, I'm going to clean the contacts on these wafer switches and see if we get some proper operation here. I'll do that next and then come back. I showed this in another video, but I'm going to repeat it again because I think it's kind of important. Of course, deoxide, our old friend here, is what you want to use, but you don't want to just go and spray down in here and let that stuff run all over the place. Plus you use 8 times as much as you need. Spray a little in a cap, stick a paintbrush in it, and then go in and let's see, well, I don't have enough light in there for you to probably see it, but anyway, go in there with a paintbrush and paint the contacts with deoxide, and then turn the switch a bunch of times, and that usually works pretty good. You use less of the material and you don't make a big mess inside. Well, I got this thing working. What I had to do, I had to input an external 5 megahertz signal to get it to operate, and that goes in the back here. It's got a input for a frequency input of 5 megahertz, and it's somewhat working here, as you can see when I change. Here's the megahertz digit. There's 4. It's running a little low. All the digits are 0 except for the megahertz, and it's reading 3.965. There's 5, it's reading 4.9. 6, it's reading 5.9. 7, 6.9. 8, 7.9. So that's working. And this one is working. You can see the 1/10 of a megahertz. But then when you get over here, this one is working. Okay, this one's working. Now this one is working, and it wasn't working before. And I had a problem with the output level. I can adjust it now, but before, I'll turn it off, back on, and now it's working. I wonder if I have a thermal problem somewhere in there. The output is working now. There's 5 megahertz and it's reading 4.965. That should be 10 megahertz. That should be 10.1, and it's reading 10.0185. I know this 5 megahertz reference is accurate. It's an ovenized oscillator. I've got the scope on the 5 megahertz reference output, and I'm getting, you can see on the scope over there, 0. So now I'm going to connect this external 5 megahertz reference and watch what happens to the oscilloscope. There it is. For some reason, this is the 5 megahertz input. It looks like our input reference in this unit isn't working. And according to the installed options, we're supposed to have an internal oscillator, so I don't know. I'm going to have to look into that. Now with the external reference on, I've got control over it here. Here's another clue. When the function switch is in the 1 to 12 megahertz position, if you rotate this control to 12 or above, this invalid frequency light is supposed to come on, and that's not illuminating. So whether the LED's bad, and these are old LEDs. This one's working alright, so is this one. whether the LED is bad or it's not getting the signal. So that should be illuminated at this point here, and it's not. Well, I've got some output, but this thing is really off frequency. I've got 145.1 dialed in, and I'm getting 144.697. I'm actually picking it up on an HT, and when I turn the so it's putting out RF way off frequency. We still got problems with this thing, so but at least it's nice to know I'm getting some output. You just got to find out why these 4 decades aren't working, and then why this invalid light doesn't come on, and why we're so far off in our frequency here. Well, one of the nice things about this unit is they make it easy to service because you can open the hood. By removing the screws that hold the board down, you can tilt these boards up, and that gives you access to the bottom power supply. Actually, power supply is over here. Wonder, I thought this had the internal oscillator time base, but evidently it doesn't. Either that or someone took it out. But anyway, you get access to the bottom of the board. I'll have to check out some of these solder connections here. Kind of like that. That's a handy feature. Beats having to have extender cards, that's for sure. Although I think there's one board in here you might need one. This is the A version, not the B version, so I'm going to probably find some discrepancies here. Lifting these boards up gives me access to the power supply connections here, so I can measure. Here's plus 5 volts. That's within normal limits. Plus 14. That looks good. Minus 12. That looks good. Looking on the other side. Five looks good. 14 looks good. Minus 12 is within limits, so power supplies are looking good. I should probably check the ripple voltage on those supplies. There's a little bit of a hum, but I don't know if that's just the transformer. The filter capacitors are buried in here. I'll have to turn it over. Oh gosh, I just noticed something here. We're missing something. And I bet we're missing a capacitor. These screws here are obviously some large filter caps, and I've got here, one was removed here. So I'll have to check that. What happened there? Well, on further observation here, this answers the question as far as the capacitor. Evidently C1 went bad, and this is C2 and C3 here. Anyway, they replaced it with 2 parallel caps here to get the capacitance. So I thought that they had to pull the capacitor out, but they just put it on the other side of the board. And there's a lot of room in here, a lot of real estate. This is one of the nice things about some of these older units. Here they give you an extender card here if you want to work on some of these boards. Plug it in, and your other board plugs in like this. So that's kind of nice. Handy to have. I'm going to clean some of these contacts off. I imagine these haven't been removed probably since this thing was made, very likelihood, so that might cure up some of the problems I'm experiencing right now. This is a power supply board on the 6160A, and this is a schematic of the 6160B, and luckily they're the same, and the boards are the same. Here's the layout's the same. That big capacitor that was missing that they had replaced with C1, that's a 15,000 microfarad cap, and I need to check that yet. But what I wanted to do, it's kind of routine. On the power supply board here, I've got a number of tantalum caps, but there's two electrolytics, these blue ones, that these tend to be bad, and I tested all the caps. All the tantalums are okay. These two I'm going to replace. These are 470 microfarad caps at 6.3 volts, and the ESR on this one, this is C2, the ESR was 0.52, but the ESR on C11 here was 11 ohms, and that's too high. So I'm going to replace both these electrolytic caps. I'm going to clean these contacts too. These board contacts, they're plated boards, but looks like they're tin plated, I believe. They're these boards have probably been in this thing for many decades, so I'm going to clean those before I put it back. And then we'll do a test and see what we find. I'm not optimistic that this is going to solve some of the problems I have, but just as routine, it's good to check some of these caps, especially these old blue electrolytics here. Those two electrolytic caps have been replaced here, and the ones I replaced were bad. These, when you see these blue ones that are, well, let's see if this is the manual for the B unit here had a date of 1971, I believe it was. So those are probably original caps. So I'm not surprised that they were bad. The rest of these are all tantalums, and they all tested good, believe it or not. So I'm going to put this board back in. One thing I noticed too, down here, the time base oscillator's gone. Should have gone in this socket here. So that's why I had to feed in 5 megahertz from that external reference. But this whole section here, I've got quite a bit of room. What I think I'm going to do is use one of those 10 megahertz ovenized oscillators that I bought, and I'm going to run the output of that probably through a Schmidt trigger gate, square it up a little bit, and then I'm going to divide it by 2, get 5 megahertz, and then I'll inject that, and that will be my time base for this unit. Well, the unit seems to be operating correctly now. I have 1 megahertz dialed in on the input here, and well, we're 1 cycle off, so that's not too bad. So let's try dialing in. I want to go to the next band here, 10 to 160. So this will be 10 megahertz. And it's showing we're 4 cycles high, which, considering the fact this thing has been sitting for who knows how long, one other thing I need to do, this 5 megahertz oscillator here, this is a surplus Hewlett-Packard time base. It's a 5 megahertz output, and that's the only reference I had, and this one may be off a little bit. So what I think I'm going to do is use one of those oven control oscillators I had in one of my previous videos, and I'm going to divide that. They're 10 megahertz. I'm going to divide that in half for 5 megahertz, and there's enough room in here underneath by the power supply that I can mount that, so that will be the reference for this machine here. Right now I'm just feeding in 5 megahertz into the external reference in, and as I found out, there was no time base in this thing. That was removed. So anyway, let's try a couple different frequencies. Let's try 100 megahertz. Okay, we've got 100 megahertz. Okay, that looks like 100 megahertz. Yes, 100 megahertz. So that's right on the money. So let's try 100.05 megahertz. And it looks like we got 100.05, although it's off a little bit. This thing is going to need some type of an alignment in it. Make sure I've got an accurate time base. I'll go through the adjustments on this thing. I do have the 6160B service manual, and from what I can see, they're pretty close, so I should be able to use that data to adjust this thing. So anyway, here you can see the output is adjustable. Anyway, I think that'll do it for the Fluke 6160A frequency synthesizer. This will come in handy, and from plus 3 dBm to plus 13 dBm, this will be nice as a signal source for some of my experiments. So, I hope this didn't get too long. I hope you enjoyed it. Thanks for watching, and we'll see you in the next one. Bye for now.